Let me introduce myself. I'm Randy Heiler. I'm co-chair of the Spotlight on Science Committee here at the library. And I'm really excited to welcome you to our season finale of our inaugural season of this new program. Okay, this is the latest edition of many of Newport Beach Public Library Foundation's roster of outstanding programming, which brings us together to hear from the world's leading authors, artists, journalists, doctors, and scientists on topics of interest, relevance, and importance to our community. The objective of the Spotlight on Science series is to pull back the curtain a bit on scientific research in an understandable and accessible way, and to highlight the importance and potential impact of these endeavors on our lives and our communities. Future installments in the series will be covering topics such as energy and transportation, our planet, the human body, the worlds beyond Earth, and emerging technologies. So we hope to see you for next season, which begins on October 2nd. And hopefully many of you are already familiar with our many other programs here at the library. The Witty Lecture Series, which showcases distinguished speakers. The Library Live brings authors of renown to the library. The Financial Literacy Workshops provide up-to-date information on managing your money and your estate. The Medicine in Our Backyard highlights the latest in health and medical advances, and the Book Discussion Group is a lively conversation on books of great interest and acclaim. But the Foundation also supports innovative library resources like the Media Lab, the self-checkout computers, the tech toys, the Wayfinder, the eBranch of the digital resources here at the library. So because we cannot present these many programs and support the library funding for all these without your support, of course, I'm here to pitch you to either join or renew your membership in the Newport Beach Public Library Foundation, because it benefits all the families in Newport Beach and surrounding communities. So as you can see, this is a fairly confined space. We have many programs where people are spilling out into the hall, and this multi-purpose room has served us well for now 30 years, I guess, almost, but we are hopefully going to expand that. Not hopefully. We accepted a challenge to raise 50% of the funding for our new hall here. This is going to be called, it's really a civic auditorium. It's not just a lecture hall, and it's going to be for the whole community. It's called Witty Hall in recognition of the generous gift by Bill Witty and Keiko Sakamoto, and it really, truly will be a community asset and will support literary, cultural, artistic, educational, and yes, even business events for years to come. As you can tell by the mess in the parking lot, the construction project's now underway. However, commencing construction does not mean finishing our fundraising. So we have made significant progress. We have raised nearly $9 million to date. However, our tab is 12. Let's pause for applause. However, our tab is going to be $12 million. So we're still looking for another $3 million. We urge you to join us in making this vision a reality. And in addition to our CEO, Gerald Capel over here, who would be happy to talk to you about it, we accept Amex, Venmo, PayPal, Zelle, and any other popular credit cards. And I'd just like to note from my own experience that this central library was also built on a public-private partnership. The foundation was created to help raise, created to raise 20% of the funds for this exact building. So this was led by a vision of the Starr family and the community and the city council. So there's a great story here, and we want to continue that story in a partnership with the city. Okay, so tonight we are very excited to introduce our final talk of this year's Spotlight in Science, which has been exploring as a theme how AI is supporting our efforts to better understand all parts of science, but specifically climate change. Our last presentation was Tracking Ice and Water in a Changing Climate. And this told how we're monitoring our planet's glaciers and ice caps and using AI to help analyze the overwhelming amounts of satellite, terrestrial, and oceanic sensor data to help understand and predict sea level rise, changes to our ocean currents, etc. And tonight, we move more locally to our coastlines. Many of us experience these extreme changes in the sand levels and tides during the year. What is happening? And is this permanent? Can we do something about it? What are the patterns and possible interventions which have been proven to work, and what are potential costs and consequences? So tonight's talk is entitled Digital Tools for Projecting Coastal Erosion and Flooding. but it might also be called What's Happening to Our Beaches and Coastal Areas and What Can Be Done to Manage and Protect Them. Our speaker tonight is Dr. Brett Sanders, who is a professor of civil and environmental engineering, urban planning, and public policy at UCI. He received his BS in civil engineering from UC Berkeley and his doctorate from the University of Michigan. His research and teaching is in the area of flooding and erosion hazards. He'll tell you how he has a passion for water that goes back to his early childhood, and developing simulation technologies to help create better policies for management of our coastal areas. He's presently leading flood risk adaptation research projects in both Southern California and Southern Florida, assessing factors such as rising sea levels, increased participation, aging antiquated infrastructure, and developing adaptation strategies for these regions that are both cost-effective and, importantly, fair to everybody. Dr. Sanders is a fellow in both the Engineering Mechanics and Environmental and Waters Institutes of the American Society for Civil Engineers. He's a fellow of the Faculty Academy for Teaching Excellence, a recipient of the National Science Foundation Career Award, a member of the Science Advisory Panel for everybody's favorite, the California Coastal Commission, and the recipient of numerous teaching awards at UCI, where he's been since the late 90s. So last year, he was also recognized as one of the 100 most influential people of Orange County by the OC Register. So please join me in welcoming Dr. Brett Sanders to the library.
Well, thank you, Randy, for that, great introduction, warm introduction. It's really a thrill for me to be here in Newport Beach and to talk about the research, I've been doing at UC Irvine for some time, share with you some of the latest work that we're doing, and also share some ideas that I think can help us, to work towards a more sustainable future for some of these challenges like flooding and erosion. It's also kind of an honor to be batting cleanup tonight after my colleagues like Eric Vigneault and Isabella Vellaconia and Padraig Smith and others at UC Irvine. So great to be sort of at the plate and here to share a story linking these problems of coastal flooding and erosion to some digital tools. I'd like to acknowledge the group of people that have kind of been with me for the last few years working on these problems. At UCI, Joe Schubert, Daniel Call, Ari Levinger, Eva Martin, Professor Katie Mock, and Professor Pietro Melillo. Professor Mock at Miami has expertise in adaptation sciences. How do we work with people to kind of transform our environment to make us safer, and some of the policy and social science aspects of this work. Professor Melillo is an expert in sort of satellite-based remote sensing with synthetic aperture radar, allowing us to kind of develop new technologies for monitoring beaches. I'd also acknowledge that, we hustle to bring in money to pay everybody's salary. Just in case you were at the universities, we write proposals, we get grants, we take our grants, we fund our students, we fund our postdocs, we pay our summer salary. And I'd really like to acknowledge NASA and NOAA and the National Science Foundation and everybody's friend, the California Coastal Commission, who reached out to me through the City Dana Point last year to kind of support a project studying coastal erosion in Orange County. So you can thank the California Coastal Commission for sending money to UCI to help study our beaches. I'll start with the take-home message, where I'm headed today, what we're going to do. Southern California, like many areas of the world, is experiencing increased flooding and erosion. I've got a photograph here on the right of the railroad tracks in San Clemente, where we've lost a beach. We've lost a beach. Orange County is losing its beaches. A railroad track that was destabilized by beach loss and a landslide. It's a crisis in southern Orange County. Left-hand side is a photograph from this January in San Diego, where some convective rainstorms formed over the city and just dumped a lot of water near downtown San Diego and caused a lot of flooding in an area that was inhabited by a lot of low-resource populations. And it turned out that the area that flooded was a 100-year floodplain. It was an area known to flood. But one of the problems there that exacerbated the flooding was that the infrastructure wasn't maintained. Drains were clogged, debris and vegetation had grown in the flood channels. And so sometimes it's not just about how the infrastructure we build, but it's also how we maintain it. Do we have funding to maintain it, and so on? Okay, so we're facing a problem. These problems can be managed, but the adaptation required presents a wicked coordination problem and will be costly. One of the biggest problems we face isn't that we don't have solutions. The problem is that Coastal Commission has to work with Regional Water Quality Control Board, which has to work with the city, which has to work with the county, which has to work with Fish and Wildlife, which has to work with Army Corps of Engineers, which has to work with FEMA, which has to work with your city council. This is the problem, right? And so how do you bring all these people together in a more effective way to tackle these problems with some solutions that make sense? And how do we make this happen faster and make it more affordable? So the answer is that digital tools give us some hope that we can pull people together to identify the issues, get people on the same page, and implement some fair and effective solutions. So that's kind of the message tonight. So let's get into it. We'll cover flooding and erosion hazards in Southern California and the case for these digital tools. We'll transition into a project we have funded by NOAA, which is modeling flood risk futures across Los Angeles County. Then we'll get into the satellite tracking of beach loss for Orange County. So data on our beaches, how are they changing? Why are some beaches going up and some beaches going down? And then we'll wrap up with some ideas about some sustainable solutions for Orange County. So the first part, this is a map of the Los Angeles metropolitan regions, Inland Empire, Orange County. We've got something like 18 million people and a $1 trillion economy, which is sitting surrounded by mountains. And these purple areas are areas that are more disadvantaged communities. And this is an area that's surrounded by natural hazards. We've got, along the coast, we've got waves, wave events that can roll in and cause coastal flooding. This is a photograph from near Mission Beach in San Diego, which is a little bit outside the map, but it was such a good photo I couldn't leave it out. Photograph of wildfires in the mountains around Los Angeles, and so San Gabriel Mountains. Those wildfires then strip the mountains of their vegetation. Rainstorms come, mobilize sediment, and we're left with mud and debris clogging our infrastructure. And you lose the capacity of the flood control system because your system is now controlled, clogged with sediment. And we also have flood channels that were engineered for a certain capacity. We want to contain, say, a flow of a certain amount, but over time we say, you know what? We want to have more natural features in our stream, so we're going to sort of support vegetation and ecosystems by changing those channels, and that delivers a new set of benefits at a cost, which is one of the costs is less flood capacity. So we have these trade-offs taking place. So we've got this region which has got these interconnected set of hazards, and over time, we've had some pretty serious flood events. This is a photograph from the 1930s when one of the most damaging floods we've had in Southern California. This is the Los Angeles River that flooded and bridges broke down, and there was flooding all along the coast. This is a sketch of the flood zones that occurred with the New Year's Eve flood of 1933. And there is an amazing, as a library foundation, there is an amazing story held in the archive, I think the digital archives of the Smithsonian, of Woody Guthrie. People heard Woody Guthrie? You heard of Woody Guthrie? Woody Guthrie recounts the New Year's flood in an interview. And he talks about the cloudbursts coming and the rain coming down and all the gullies and all the washes getting washed out, and all the Okies who had come from the Midwest, and they'd settled in California, and they'd settled in all these ravines and all these arroyos, and they were all washed out and killed, and hundreds of people were killed. So that's a beautiful recounting of the hazard, the sort of event that took place. And it was after that event that the elected leaders of Southern California were successful going to Congress and getting funding for flood control systems that would provide protection for the region. And what they designed and what they found worked well was an infrastructure design that captured the mud and debris in what are called debris basins. Up at the foot of the mountains, we have debris basins all across Southern California, Los Angeles, Orange County. And the idea is that when the mud and debris comes off the mountains, that will first collect in the debris basin, and then we would have these sort of engineered, really streamlined channels that would sweep the clear water and any fine sediment downstream towards the ocean. So the infrastructure philosophy at that time was to provide protection against these really damaging floods that were a threat to people's safety. And they were also a barrier to economic growth. You couldn't grow an economy if the rivers kept changing course every year and disrupted business and growth and housing and everything else. So this was the infrastructure design that we sort of bought into as how we're going to manage the hazards. And we built infrastructure like this, which was sort of engineering concrete, hard surfaces. This was the type of infrastructure we invested in. And it's worked. It's actually worked pretty darn well for containing big floods. This is a photograph by an artist. His name is Kevin Brake. He has a studio in downtown Los Angeles. And every time there's a big storm, he likes to run out and take photographs of the river to see what it looks like. And here's a little time-lapse photography of the Los Angeles River near one of these sort of Gothic bridges. So this is the infrastructure. These are our rivers. And let's go back a second here. Oh my goodness, I need to go. Can I go back? Oh, here we go. Okay. So this was the infrastructure type that we invested in. Infrastructure that was good for flood control. It was good for economic development. It was good for safety. And then there was a really important act by the state of California in 1945. And you can't read all this, it's too fine. But it was published in a paper in the 1980s. It's a really fascinating little nugget of information I'm really delighted to share with you. So I'm going to read it. So it reads, the state's flood control policies were enacted in 1945. The California legislature had a problem in 1945. It had to decide what to do with an enormous budget surplus, which had accumulated during the war. It decided to spend the money on a scatter of capital improvement projects, mostly local government programs. Flood control was one of the lucky winners. What this meant, 1945 Flood Control Act passed. The way the federal government supports flood projects and a lot of big water infrastructure projects is that they, in the case of flood control, they will provide the engineering, they will provide the design, they'll support construction, but they expect there to be a local match.
Oh.
They believe in matching, okay? So you put in your 20% or your 10% or whatever the matching requirements are for that project, and Uncle Sam picks up the other 70 to 90%, whatever that might be. Okay? So the legislature decided with its massive surplus in the 1945 that the state could step in and cover the local match for communities that needed flood control. And that gets us to this next paragraph, which says that at this point, it should be spelled out what always seemed obvious but may not in fact be. That is, during the years in which this policy was applied, there was virtually no way that local officials could say no to a local flood control project. It did not cost them a cent, and it made developers and other boosters happy. The point is that if you were an elected official and you got put in with support of developers or the boosters of your area, all you had to do was write a letter and you were done. You could fund a flood control system and someone could develop the land. And so what happened across all of California? We built out like tons of debris basins and dams and flood control systems, all using the same technology. So this technology that we invested in, which was all about hard solutions, was rapidly applied across all of California precisely at the time that California grew like crazy after World War II. And so all the urban areas of California are utilize some of the same technologies, these streamlined channels that just have no nature, right? There's no green in a lot of our flood channels. It's all about hard solutions. And many decades later, we have some problems. Southern California beaches are running out of sand. January storms leave flood-controlled dams at risk of overflowing. They're filling up with sediment. We have rivers without vegetation and soil, no shade, poor water quality, no habitat for ecosystems, no green space for human well-being. More and more research is telling us that people are healthier when they're around nature. If air quality is better when there's trees and things like that. So our 21st century needs aren't being met with our 20th century designs for our flood infrastructure. We don't have infrastructure that's good at water conservation. We don't have water infrastructure or drainage infrastructure that's good for access to nature, urban cooling and air quality, sediment management, fish and wildlife. And now we're facing a changing climate where there's more intense precipitation and the possibility that this infrastructure could be undersized. Along the coast, we're facing rising sea levels. So there's all these pressures to say, you know what, maybe now's a good time to rethink and redesign our flood control infrastructure. And I think the good news here is that there's high potential for really a multi-benefit transformation. This is the Los Angeles River today. This is Santiago Creek in Santa Ana, in Santiago Park, which I think is a beautiful example of how you can combine hard and soft elements to come up with a channel design that has multiple benefits. You've got a soft bottom here. Sediment can be pushed downstream naturally. You've got an exercise path with shade from trees. I mean, how many flood control channels have you seen across Orange County? There's no shade. You're out there in the wind and in the bright sun, there's not shade there. And these are oak trees. I mean, beautiful oak trees along the stream. So there's access to nature. And so the potential is high, but coordination itself is a really wicked problem. Federal, state, local government agencies, community, tribal groups, private sector, permitting, funding, timing. And you got the trade-offs between all the benefits and costs and projects. It's even when there's funding, sometimes the timing's not right. Oh, we can't do it now because it's nesting season. I mean, these are things that come up as we try to come up with solutions, right? And so coordination is a really challenging problem. And most people in government want to do the right thing, but they're often confined to, somewhat of a silo in terms of, and so that we need to kind of create more tools, more opportunities to coordinate across those different agencies and entities, and that's where these digital tools can play an important role. It was around a decade ago that I had a project funded by the National Science Foundation to co-develop some flood hazard models representing sea level rise. And I came right here to Newport Beach, and we did a survey of households all across Newport Beach and asked people, about their awareness of flooding and how our simulation compared to their awareness, So our work really trying to use digital tools to help us understand awareness of these hazards and what people thought about them and what should we do about this thing. That work started basically a decade ago here in Newport Beach. And what we found is that these tools help diverse groups of people with different backgrounds and different interests kind of hone in on what the key issues are and so they can bring their experience, what they care about, into an issue, and then have a more meaningful conversation in exchange about what is it we're scared about? If there's a flood, what do we want to protect? What's the cost of doing that? What are the benefits of doing that? And so you can start working through like some solutions. So we have a story here where like this process of collaborative flood modeling, where you work with communities to get a sense of, what kind of scenarios do we want to look at? What kind of future scenarios, past scenarios? What do we want to map out? That can be an iterative process, and through that process, you can come up with a set of plans and responses that are reasonable, that sort of have a reasonable level buy-in across a lot of different stakeholders. So there's no recipe for precisely how to do this, like exactly how many people do you talk to and what kinds of formats to use to talk to people. Is it a workshop? Is it a survey? Is it an online forum? We're trying to get at that a little bit with a project in Miami. So we're working with the South Florida Water Management District, who has immense flood risk problems with hurricanes and storm surge and intense rainfall. And we're going to be doing some experiments where we test out different ways of using digital tools and to see whether that changes the kinds of solutions we come up with versus projects that today tend to be designed mainly by Army Corps of Engineers or flood control districts or consulting engineers who often represent some sort of influential stakeholder. So there's kind of a power imbalance where there's not sort of a even say in terms of what kinds of projects we build. And when you talk to people who work in like the engagement space, trying to work with the public on trying to get impact on public projects, they'll tell you that these community groups that are trying to shape these public projects, they're exhausted. They feel like they come into projects, all the important decisions have already been made. Maybe you feel that way, where the city's going to do something, they've already decided what they're going to do. It doesn't matter what I think. And can we change that? Can we create a future where there's these digital tools that allow people to get a better sense of what is it they want to do? Is that something that I think is a good idea? And the idea of the digital tool is that you can get a better sense of precisely what they're talking about versus what your worst fear might be. And oftentimes that's a big difference. Like one of the things we found here in Newport Beach when we did our sea level rise a long time ago is that before we did our work, there were a lot of concerns about how severe flooding might be. Am I going to be like flooded out? Do I need to leave? And the modeling showed, well, it's like ankle deep water that we're talking about for 2050 that might happen once every 50 years. Oh, well, that's a different problem, right? So if the visualization or the simulation gives you a better sense of what the issue is, less uncertainty, and it's easier to make progress. So that's the idea behind the sort of digital tool. And obviously there's like really creative things you can do to try to pull people into understanding what you're planning and get feedback on plans and so on, like immersive technology. This is a project in Australia, in the city of Brisbane. They're planning a new rail project, and they've got this massive digital twin of the whole project planned out and can visualize what every train station looks like and whether the lighting's going to be good in the station and all sorts of issues they can work out with the digital tool ahead of time. So that's the case for the digital tool, okay? So now we'll say a little bit about what we're doing with it in Los Angeles, where our work shows that there's somewhere around 400,000 people exposed to like a 1% annual chance flood, exposed to more than a foot of flooding, and something like 56 billion in property. So we had a paper that was published last year, and revealed that the flood risk across the county is probably at least an order of magnitude greater than what FEMA maps would have suggested. And there's a couple of reasons for that. One is that at the time FEMA did their mapping, the main stem flood channels were not considered to be undersized to contain a 100-year event. So when we did our modeling, we show that the water spills over the sides, causes a lot of flooding, and so that was one driver of increased flood hazards. The second, you might not realize this, is that FEMA doesn't require, when you map floods, to account for rainfall hitting the streets and sort of the street flooding that happens. FEMA is not required to map out street flooding hazards from intense rainfall. They only map out hazards from rivers that can't contain flood peaks and coastal areas that might have a storm surge or high tide, something like that. So when you account for like the street flooding piece and you account for the channels that are undersized, we ended up with a risk that was like at least 10 times greater than what was mapped. So now the question is, well, what can we do about this? How can we manage this risk? And And the way we're going about this with NOAA is we're trying to do a project where we study sort of what is the play we have in the system. If we use, say, nature-based solutions versus hard solutions, how much of a difference could we make? And what kind of benefits might we get if we took a different direction than some of the hard solutions we've used in the past? So we're trying to sort of show that there's a trade-off we're having between maybe some of the economic benefits versus some of the social and environmental benefits. And what we're doing through a process that's hosted by an organization called the Los Angeles Area Regional Collaborative for Climate Action, or LARC. They are an organization that specializes in bringing private and public groups together, nonprofit groups, public agencies, around different types of adaptation needs and exchanging information. So they facilitate a set of meetings where we can say, look, we've got this model. We can simulate flooding in a future where we have wider channels or different levees or more stormwater capture or more green infrastructure. Why don't we use this tool to kind of collectively learn what's possible in the future with different types of infrastructure investments? So that's what we're doing. We're exploring 3 specific options, like an option that's mainly hard solutions, which is levees and dams. An option which is, the idea is to go with, what if we widened all these channels and went with soft, more natural features, more river restoration? It would be really costly. You would have to buy up a lot of land. So there's going to be different trade-offs for each one. And the third option we're exploring is a stormwater capture option. And then, in addition to that modeling, the question is, how do you tell whether one is different or better than the other? It really depends on what metrics you use to quantify the difference between the different options. So we're also working to try to come up with some kind of a evaluation framework where we can look at, for each option, what are the merits from an economic perspective, a social perspective, and an environmental perspective. And the idea here is that we're not going to be able to design a perfect solution, okay? What we're able to do with the tools is lay out, sort of a mapping of what the different options are, what are the benefits of those options, and create a more informed conversation. So the stakeholders who have to kind of decide what to do have some sort of a scientific underpinning of the benefits and trade-offs of those different options. So this project is undergoing, and I just wanted to give you one example, and this is the most detailed picture I have. So if it's hard to see, I'm sorry, but this figure on the left shows 4 different flooding scenarios, and we'll start with this one here, which is the flood hazard that the area faces today, the 1% chance flood, also known as the 100-year return period flooding hazard, okay? So with our modeling, we're able to say, okay, what's likely to flood? And then we can say, what would be the damages from that flooding? We also could say who would be exposed to that flooding. So we can get measures of both economic losses and who's impacted. And then we can say, well, what if we mitigated that flooding by raising levees everywhere? So the mitigation scenario corresponds to like raising levees all along all the main stem channels by 1 meter. And we see, I'll kind of walk through the results on the right-hand side in a second, but first I wanted to explain the options. The graph on the top corresponds to what if we could like capture so much water upstream that we lower the flood peak coming into the main stem system. So that's option number 3, is a stormwater capture option, okay? So the idea here, and we also have, what if climate gets worse and we have like much bigger flood peaks in the future as a more severe flood comes? So we have baseline flood today. We have the model scenario where let's raise levees. We have an option, what if we could reduce the flood peak? And what if the flood peak gets worse? Okay, those are kind of the 4 options. Over here on the right-hand side, I'll point up here, this is just showing the number of people exposed, flood exposure. And the colors on the right-hand side match the 4 scenarios, okay? So if we start with this like medium, looks almost green here, bluish green, we can see that the number of people exposed is we can sort it by social groups, different racial and ethnic groups using census data. And we say, well, that flood would expose, most of the exposure would be Hispanic. There'd also be a lot of white exposure, a smaller amount of Asian and Black exposure. And then, if you looked at the mitigation project, you can see that starting here, the exposure for everyone goes down. So in some sense, you can use the data to say, look, this project offers a benefit in terms of reducing exposure for all social groups. So that's one thing you could do as a sort of evaluating a metric, a performance metric of that measure.
Yeah.
But another metric that we use is called the Gini index. And the Gini index says, is the exposure proportional to the population, or is exposure more or is a certain social group more exposed or even less exposed? So you can imagine that if there's a social group where that's underexposed, that would sort of suggest that they're somehow benefiting more from the infrastructure than other social groups. If you're a social group that's overexposed, it would suggest you're less well served by that mitigation measure. And so coming down here, under this scenario here, the baseline scenario, we reported that Black populations were disproportionately exposed to flood risk in Los Angeles County. And when we went to a mitigation scenario, that the data also shows that even though the number of Black people exposed to flooding was reduced, there was still a disproportionate exposure of Black population, okay? Conversely, there was, for flood risk, the white populations were disproportionately underexposed. The point here is that data from the flood hazard model, from the U.S. Census, can provide objective measures of who's exposed and whether it's fair. That's the idea. And then that information can be part of a conversation about what kinds of projects can we afford, where should we invest in these projects, can we tweak the project in some way so that we come up with a better mix of benefits across the social, the economic, and environmental. And that's kind of the graphic down here that is still something in the works, but we're trying to come up with a set of indicators like costs, damages, exposure, access to nature, sediment delivery to the coast, water conservation, urban cooling, nutrient loads. The idea is to come up with a sort of a dashboard of metrics for different types of interventions so that we can figure out a set of projects that make sense. That's the idea, and that's work underway. So chapter 3, which you all came here for tonight, beach erosion work. Orange County is like ground zero for beach erosion. Oh. We have got some big beach erosion problems in Orange County. This is Bolsa Chica State Beach. It's overtopped several times. There's been flooding of the highway. Cypress Shores down in San Clemente has lost its beach. Working with the OCTA has some big work on their hands to try to figure out how to stabilize their railway and also not impact the environment around it. Capistrano Beach Park washed away a couple years ago. It's not there anymore. You can see when as it washed away there in that was like 2018, I believe that photo was taken. And back, I'm skipping it. So with satellites, we can see the beaches changing. With this publicly available satellites, they get a photo of the coastline every couple of weeks, sometimes more often. And every time the satellite goes by, you can trace where the shoreline is. And by the distance between the shoreline and the back shore, you can get a measurement of how wide the beach is. Okay? And there's also buoys offshore and models that allow us to know what is the hour-by-hour statistics of the waves along the coast. So what we've been doing is saying, look, we have data on the beaches changing. We have data on the waves. We should be able to put these two things together and figure out how the sand is moving around, where it's going, why it's moving, where it's moving. That's the idea behind this research. These graphs here show what the satellite data looks like. So it's available from around 1985 to around to the present. And you can see it's a noisy signal because there's high tides, there's low tides, there's seasonal differences. Our beaches often widen in summer and narrow in winter. But you can see a trend. Huntington Beach has been growing like crazy. Huntington Beach has been growing at a rate of like over 3 feet per year since 1980. If you want sand, send your truck down to Huntington Beach, back it up. They have access issues. Like people that need to get to the water, and it's like a mile to walk out to the water. So Huntington has been growing at a really fast rate. Newport Pier, which many of you might find interesting here in Newport Beach, was stable for quite some period of time. There's some fluctuations, but over the last decade, since 2010, has shown some decline. So there's signs of a decline. And then San Clemente, where you saw that photograph of there being no beach, why don't we look at what happened there? So this is the record from San Clemente. You talk to people in San Clemente and they'll tell you, we were playing volleyball on the beach every, Thanksgiving. There was tons of sand and it just disappeared really fast. But there was some decline happening maybe as early as around 2005 that maybe wasn't quite detectable because there's so much noise. But maybe there's a subtle decline. And then we went through some kind of a tipping point where the slope of this changed, and then sort of a disaster point where the last bits of sand were washed away and the water came crashing over the rocks and onto the railroad track. So we have tried to kind of map this out countywide, like what's happening countywide with the beaches. And with the satellite data, we can map out now with this coloring scheme what areas are eroding the fastest and what areas are getting wider. So we looked at Huntington Beach. Huntington Beach here is growing at a rate of over 1 meter per year over the this is from 2000 to 2021. Sunset Surfside is an area where it's been in decline. Here in West Newport near the Santa Ana River, there's an area that's in decline, but around the pier has actually been on average widening. And then between say Newport Pier and Corona del Mar, it's been sort of in decline. But it's weak. It's not as strong as like these hot spots. And in South Orange County, a big hot spot just south of San Juan Creek, a big hot spot around San Mateo Point and around San Onofre Beach. So these are some of the hot spots we now can see in the data in terms of the beach loss. Now, we use a concept of what's something called a littoral cell in order to kind of figure out the sand budget. So just like you do a financial budget for your personal expenses, you can do a sand budget. How much sand is coming in from rivers, from nourishment projects, from whatever it is? How much sand are we losing offshore? Should the beaches get wider or narrower based on the transport of sand? And historically, people thought that the transport was mainly north to south along all of the California coast. But our data suggests it's not at all that simple. This data here takes the wave data and predicts, is the sediment transport more up the coast, which is on the right-hand side of this? Anything on the right-hand side is sand transport up the coast, and everything on the left-hand side is sand transport down the coast. And this axis here, of course, goes from Sunset Beach to Bolsa Chica to Huntington Pier to the Santa Ana River, the Newport Jetties, Newport Point, and Newport Harbor. And a couple ideas here. The solid color is the average sediment transport over that 20-year period, okay? So if you took all the wave data and said, well, sometimes the sand goes this way and sometimes the sand goes that way, what is it on average? And the gray areas is the variance, one standard deviation of that information. So in some places, sand can go both up coast and down coast. It can go back and forth, back and forth, back and forth. It's kind of like a mixer. But in other places, even the fluctuations are all sort of predominantly in the same direction. Does that make sense? So if you go, say, the Newport Jetties, right in here on Newport Point, the data suggests that the sand is transported, oh boy. Okay, back. Okay, so something you're all maybe familiar with is Newport Point. I'll be careful where I step, which suggests that on the northern side, the transport is mainly up coast. On the southern side, it's mainly down the coast. which kind of makes sense. If you're at a point, oftentimes the waves will split in opposite directions there. But there's also a seasonal difference. So in winter, there's more down coast transport consistent with what these papers had said in the past. But in the summer, it's more up coast. And why is that? I'm sure there's plenty of surfers that know why, right? It's these southern swells, right? These southern swells come in summer, and they push the sand up the coast. So that's the story with the sand, is it's mixed both up and down the coast. And we came up with this idea that kind of these fans are areas where there's strong transport in one direction, like here and here. And so transport is kind of up coast from Newport Point and down coast from Newport Point. There's also areas where sand is just kind of stirred around and mixed around by the waves. We have a nourishment project that many of you are familiar with at Sunset that brings material down coast from Sunset. But this data suggests that it probably stops at Huntington Beach, right? And it probably explains why Huntington Beach is growing at 3 feet per year for the last 20 years. Because we nourish at Sunset Surfside, the sand is mixed down the coast and then it settles out at Huntington. No wonder it's getting wider and wider and wider in the middle of Huntington. It also, we're gonna go back. I wanna put a plug for your city staff because they do a really good job opportunistically grabbing whatever sediment they can in Newport Beach and trying to get it on the coast, either from the Santa Ana River. That's really important because I don't think I'm guessing that the Army Corps project doesn't help you that much. But these local projects where the city works with the county to get sediment out of the Santa Ana River onto the beaches or out of Newport Harbor and onto the beaches, these are really important and really good examples of beneficial reuse of sediment. Okay. So I'm going to wrap up here with some sort of sustainable solutions for Orange County, how we sort of manage these beach erosion problems. There's no magic bullet here. We can do nourishment projects, but they're really costly. It costs like $30 a cubic yard of sediment or something like that. If you need like 1 million cubic yards of sediment, all of a sudden that's a pretty big price tag. I mean, OCTA is looking at a price tag of like over $100 million to try to stabilize their coast, in the near term with sand nourishment and rock revetments and things like that. So it's costly. So I think we should not take for granted the coast. It's a natural infrastructure. We pay for other infrastructure. We should, at some level, be paying for our natural infrastructure that provides a benefit to us, like beaches. But if we could reduce those costs and rely more on nature, that's going to be a more sustainable solution. So one thing that can be done, which is low-hanging fruit, which I've been speaking on it for a few years, and I'm so excited that the County of Orange worked with Orange County, with State Parks this past year, and they took advantage of sediment that accumulated in the Santa Ana River and would have ordinarily been scraped out and taken to a sorting facility in Santa Ana and then sent to a landfill or sent to a construction project. They had the sort of wisdom to say, instead of trucking it to Santa Ana, why don't we truck it down to the coast and leave it there? They're going to spend the money on trucking anyways, just send the trucks to a different spot. Why wouldn't you do that every year? Timing, like getting permits through, all that kind of stuff can be tough. So that's where timing comes in. But that's a great example of restoring like a natural process that's been undermined by sort of our infrastructure with dams and our cleaning practices. And then this is another idea which is gaining traction in Orange County, which I think has enormous merit, which is, it starts with the fact that we can start in several different areas, but we have a sediment deficit at the coast. Mm-hmm. Our rivers aren't supplying sand to the coast the way they once did, and so this coast is starved of sediment. The reason the coast is starved of sediment, first and foremost, is that we've built dams that block the flow of sediment to the coast, and our land development practices generally call for us to just hold sediment in place. We don't want to build projects where the soil erodes. We want to build projects where land is stable. Okay, so we've stopped the flow of sediment to the coast. There is a massive volume of sand building up behind Prado Dam. And there's been estimates that over 1 million cubic yards per year accumulates behind Prado Dam. And And it's been recognized as a problem for several different entities. One is the Army Corps of Engineers. They want a flood control reservoir, and the reservoir doesn't work for flood control if it fills up with sediment. Secondly, this is of interest to the Orange County Water District, which is behind the resilience of our water supply here in Orange County. Orange County Water District needs space, low elevation space in the reservoir to store water, okay? If the low elevation space in the reservoir fills up with sediment, we can't store water there anymore. The reason Orange County Water District wants to store water in there during the winter is because they want to slowly release it so it can flow downstream into Anaheim, and they can get into their recharge basins. So Orange County Water District takes water out of the Santa River, they put it into the recharge basins, that goes into the ground, and we have this massive reservoir of water underground that serves all of most of northern Orange County. So Orange County Water District would like to see that storage space so they can do groundwater recharge. Coastal communities would like to see sand coming to the coast to manage coastal erosion. And I would argue that inland communities would have something to sort of benefit from if they had flood channels that with a more diverse set of benefits. Not just flood control benefits, but what if they had access to nature? What if they had better water quality? What if they had more shade? You know, heat waves are becoming more and more of a problem. So that's the opportunity for Orange County. And I think it's an exciting opportunity, but it's one that requires a lot of coordination. You've got Army Corps, you've got county, you've got water districts, you've got cities, fish and the usual, group of agencies that all need to kind of be on board. So, wrapping up here, the take-home message: Southern California, like many areas of the world, has experienced increasing flooding and erosions. These problems can be managed, but it's a wicked coordination problem and it's costly. And the idea is that these digital tools, the data, the information, bringing people together, can help us develop more fair and effective solutions. So thank you very much.
Fantastic talk, Philip. I don't need this. Okay. So thank you so much, Brett. Very interesting. We're going to open the floor for some questions. Kunga's got a microphone. If you want to raise your hand, we'll bring the microphone to you and let you ask. Okay?
There alignment among the various stakeholder groups that you end up working with relative to defining the problem? Or are you fighting over what is the problem? You in particular, but
that's a really good question. I think we fully explored, what the interests are. If we want to do something like that,
exactly what inland communities want. I think I have a good sense of what some of the coastal cities want. I have a good sense of what Orange County Water District is looking for in the Army Corps. Not so much the inland communities. So I think there's more to be done to explore, like what are the interests. So that's where I'm at.
Hi. First of all, thanks for coming. It was a great lecture. I think you mentioned, like, on the coastal erosion side, there's a whole handful of different, like, shorter term solutions, like, potentially in San Clemente bringing 500,000 meters of sand. And then you have hard armoring solutions. And I'm wondering, from your perspective, in the short or medium term, how you think about a blend of soft and armored solutions, and if there's anything that you're excited about, like, I know in Newport the groin fields maybe have been successful, or if there's other things like that you've seen that are worth considering here.
Yeah, great question. I think there's growing appreciation that you need a mix of hard and soft solutions. I think that the hard solutions bring a sense of reliability and protection, but then they often introduce, like, ecosystem risks and risks for external impacts that are sort of a big concern. So oftentimes with, like, coastal infrastructure, some of the hybrid solutions are oftentimes you want to bury some kind of hard solution that you can count on to be a strong defense against a real extreme event that could damage like really expensive infrastructure or cause a big setback. But you like to kind of bury that under sand, under vegetation, that then offers the benefits that you would like to see from the natural solutions. And that's kind of the idea behind living shorelines, which is a emerging sort of concept that comes up. I'm not a real fan of the name because, I think it's living shorelines somehow creates an appearance of lots of vegetation. What exactly is living? There's something living everywhere. Yeah, blending hard and soft solutions makes a lot of sense. And I thought that example of the Santiago Creek channel is a really nice example of you've got some concrete flood walls, which provide some stability and that prevents the channel from just taking any particular path. At the same time, you've got some soft elements, some natural features. And I think that's really probably what you're going to see in a lot of areas where you can't afford to let nature only be the solution because it's often like very unpredictable. And it's hard for us to kind of live and work and plan infrastructure and if you have something that's highly, highly unpredictable, in terms of the amount of erosion that could take place or impacts that could happen.
Right.
When they do the replenishment projects and they start in Sunset Beach and it's coming down and stopping in Huntington, why don't they change the plan? Or why don't they take the sand from Huntington and bring it to Newport? Or just if the data is showing that it's not working properly, why don't they change the plan now?
Yeah. Well, I think the data that we looked at that shared this perspective that the sand transport might not be going all the way to Newport. This is new, okay? So it may not everyone may agree with this interpretation of the way sand is moving. So there's that, right? There's the fact that it's new. And I think it's going to take time for like the next cycle of planning to decide that next project. I mean, the engineering, the calculations that were done for the Surfside Sunset project, that project was designed decades ago. And what happens every year is it comes up for funding and people get on board and say, here's my match and off we go, right? So
I think the funding doesn't come very often.
Yeah.
Like every 20 years.
Well, right. So they plan to do it every decade. I think the plan called for like a decadal nourishment that, and some decades were skipped. I think years that the funding hasn't been available, they haven't been able to do it. But you can see that if you looked at my data, Sunset Surfside needs it for sure, because that's basically a feeder beach. So the waves pull sand from Surfside Sunset and they take it down towards Huntington. But there's several lines of evidence now that the beach is getting wider. The data point, in terms of the wave data, that suggests that it's stopping in Huntington, and that is an issue. Like in terms of the performance of the project, may not be living up to what they kind of thought it would have when they planned it.
You have a queue up here.
Yeah, okay.
Brett, how can cities upstream from Newport Beach, I'm right here. So, for example, the Newport Bay Watershed Executive Committee meets and tries to collaborate with cities upstream, but it's voluntary. So Newport Bay is a repository for everything that comes downstream. So we're constantly working on us, but it doesn't mean that people upstream could cooperate. It's voluntary. So how can we get to a point of cooperation with those cities and make it an important part of our city's future?
Yeah.
Political question for the scientists.
Yeah. Well, it's a good question, and I think that in terms of the Newport Bay issue versus other issues, I've been thinking about this in the context of beach erosion, in the sense that beaches are, in many ways, they're a driver of our tourist economy, right? And it's because of our tourist economy that we have hotels, we have restaurants. The people working in those hotels and restaurants are often living in inland areas. And oftentimes the people using the beach are often coming from inland areas. So certainly in terms of beach, I think that there's an opportunity to try to build a more shared awareness that the natural resource we have along the coast is good for everybody. I think it's harder to sometimes to make a case for upper bay water quality for birds, despite the fact that that's really important, right? I'm not saying it's not important, but I think it's a trickier case to make to the public in terms of environmental stewardship, and it's not really my expertise in that area. But I think that the digital tools do have an opportunity to kind of help people see the connections. If you could show connections between what's happening in the watershed to the extent that it's driving that, is it the being able to visualize different scenarios? If we implement this measure upstream, and then models can be helpful for that kind of thing. That's a strategy, but maybe no magic bullet.
Next question.
So you've alluded multiple times and fairly to the issue of getting permits, the whole permitting, and state, I think it's the California Fish and Wildlife, they have the thing called green permitting. They're trying to streamline it. But it would seem to me that what really needs to happen is that there needs to be a larger coordinator. In industry, you have people who are called expediters, and they run around and they track things and make sure things flow and everything else. And I know in the Santa Ana River, there's probably 10 entities that you have to get approval if you want to do anything over there, which usually takes about 10 years, 8 to 10 years. Is there anybody looking at some kind of coordination between the Corps, U.S. and California Fish and et cetera, all these entities, flood and so on, to try and get this permitting coordinated? And you mentioned the digital aspect, and I'm wondering if maybe there's an opportunity for everybody's dumping on AI, but maybe actually using some of the latest technology to try and do a little more coordination between the entities. And I know that you're a scientist, but maybe somebody at UCI that is involved with logistics might tackle that.
Well, in the point, I think completely agree that that the coordination piece also applies to the regulators. Get the regulators involved early in what you're planning, get their input, so that when they see a project, they're not seeing it for the first time. In terms of the expediters, I think it's a great idea, and I don't know how you would implement it, but it's something that could be examined. I think it's a great idea to look at that more and to learn from the private sector what they've done to kind of make things move faster. We have written some papers on barriers and opportunities to manage sediment better, and so we have done research. I'm not the lead on that, but my colleague Professor Nicola Ulibarri is an expert on sort of regulatory processes and governance and permitting and things like that. And we also have shared some of our findings with some of the elected leaders who passed legislation on trying to cut green tape and things like that. I'm not sure if that legislation had much impact in the end. The state legislation can only do so much with federal entities as well. But I couldn't agree more. I mean, the permitting, it's the coordination problem that really, really jacks up prices, makes things take a really long time. And we can't afford to be waiting this long to get some of these solutions implemented. So
just wait till we talk about the energy problem. Okay, so let's move on to the next question.
Thank you for the question.
On the beach erosion map, why the gap between Corona del Mar and Dana Point?
Oh, great question. Where was that coming from? Oh, okay. Thank you. So Laguna Beach, which sort of sits between those two areas, is filled with a lot of pocket beaches where you have headlands and small pockets, and it's a tough area to use the method because it tends to be more fragmented and it's hard. But we have looked at the historical trends in Central Coast beaches, and they've been fairly stable compared to other areas. Where we have looked, we haven't seen long trends of declining beaches, but we do see fluctuations. And it seems like the area is characterized by fluctuations, possibly with sand shifting to either sides of coves, right? So if you get westerly waves, the sand shifts to one side. Southerly waves, it may shift towards the other. But it's that's the reason our method wasn't really a great fit for these smaller pocket beaches, and that's why we weren't able to kind of get in there. But I'd like to do that in the future. I'm excited to do that.
Okay, I'm going to give two more questions, and they're coming from the front here because I've seen these hands up for a long time. We will have some time afterwards to continue questions.
In addition to that, the plus has been talked about managing the holiday method adapting to the breathing sea.
Yeah, great question. We've come up with a new name for managed retreat, by the way.
Good.
We're going with strategic realignment.
Yeah.
Strategic realignment. No, it's strategic realignment is something that is has to be part of your toolbox. I mean, there's certain places that it's just impossible to kind of hold the line without causing negative impacts around you or doing something you just can't afford. So it's always an option. And with beaches, as right now, the problem we've been managing for the most part is not a sea level rise problem, right? But sea level rise in the future is going to make this a bigger problem. But as sea levels rise, for thousands of years, beaches have gone inland and seaward as the beaches just shift to where the coastline is. The problem is we've cut off the sand supply. So no matter where the sea level is, if we don't have a supply of sand, we won't have a beach. But the managed retreat and the strategic realignment is saying, if we just stay in one place and we don't shift inland, then your beach gets steeper and steeper and steeper, and it's not a sustainable beach. So you reach a point where it's difficult to stay in place.
Yeah. Okay. Final question. Yep. Okay.
Thank you for your presentation.
On the slide,
Slide showing the channelized portion of the Santa Ana River from Yorba Linda down to Huntington Beach. Are there any studies in progress to identify areas of priority to ameliorate, because seeing down, I think, land water interface in Port Estuary, where a lot of algal blooms occur downstream more and more with intense storms. Is there any work, I know there's a lot just talked about the complexities of permitting and overlapping jurisdictions, but what about like California Coastal Commission? I know they go inland about 5 miles in certain areas. Could they possibly take over instead of federal? I don't know how thanks.
To the coast is, I think there's some sort of coordinated work between the County of Orange and Army Corps that has sort of designed and maintained that, and so plans to do any kind of restoration of that are just like, at this point, I'm throwing it out there as something we should be thinking about, and I don't think anybody's in these government offices is penciling out any project at this time. But the reason why is I want to raise the issue because you can see that if you're just working on managing a flood channel, you're not seeing the connection to the beach or the connection. You can start seeing that you have to step back sometimes and see that we've sort of boxed ourselves into a corner, and unless we do some significant transformations, we're going to be left with a set of infrastructure that just is really costly and causing a lot of problems. So it's early in the process of any of this happening. And what I've been trying to do is just try to stimulate some thinking about what we could be doing differently, and maybe we'll get some traction about that. I agree. If we were going to be restoring channels, then we have to think about what are the ecosystem benefits we could offer, and what do we want out of that design? If we're going to restore the Santa Ana River to be something more natural, what would that be? And that's an open question.
Great. Thank you. I'm going to cut off the formal questions here. We'll be around to mingle. I'd just like to request of everybody, great engagement tonight. Thank you so much, Brett. you should be sharing with your friends about this program, about this library, and helping us join in improving the audio-visual experience from kicking out the cord to flaky microphones, and join us in supporting Whitty Hall. Thank you again, Brett, for a fantastic presentation.